In this lecture, let's control the flow of logic with conditional statements. So far, we've been executing code immediately. We may not always want this to be the case. Specific pieces of code should be executed when a condition is met. For example, if the player is within proximity of an enemy, the enemy should chase the player. If a player's health drops below 0, the game should end. Performing actions based on a condition is known as control flow. Let's update our robot to check the new price. At the moment, we're immediately applying the discount. Before applying the latest price, we should verify the price isn't too low. Otherwise, we may not be able to make a profit. Inside the script, let's assign the return value to a new variable. Rather than updating the price variable immediately, we'll store the new price in a temporary variable. After confirming the price is not too low, we'll update the price. Set the variable name to new price. Next, set the type to float. Unlike before, we're not declaring the variable from the class level. Instead, it's being defined from the method. The main difference is the accessibility of the variable. By defining a variable on the class level, the variable is accessible to all methods, whereas variables defined from within a method are only available from the method. Next, let's try updating the quantity to 1. It'll be easier to keep track of the price when there's one robot. After defining the variable, add the if keyword. The if keyword creates a conditional statement. Conditional statements are lines of code that perform a check based on a condition. We can write the condition by adding a pair of parentheses. Within these parentheses, add the following code. New price greater than 75F. I'm introducing a new operator called a comparison operator. In the resource section of this lecture, I provide a link to a complete list of operators. As their names imply, comparison operators will compare two values. There are a total of 4 comparison operators. They're mainly used with numbers. After performing a comparison, the operator will create a Boolean value. We can use this Boolean value from within our conditional statements. Let's head back to Visual Studio Code. Conditional statements may only accept Boolean values. For example, if we were to remove the latter portion of the conditional statement, an error would get produced. In this example, we're passing in a float value, which is not accepted by C#. Let's revert the condition. Luckily, comparison operators create Booleans. If the new price is greater than 75, we can consider the new price to be safe. Add a pair of curly brackets. Code written inside the curly brackets will be executed when a condition is truthy. Let's set the price variable to the new price variable. What if the price isn't greater than 75? In this case, we should reject the new price. This step is optional. If an if condition fails, we're allowed to create a default response. After the if statement, add an else statement with curly brackets. The else statement will run when the if condition fails. There's one rule for using else statements. They can only be added after the if statement. If we attempted to write code between both statements, we would get an error. The order of statements does matter. Inside the else statement, let's add a method called print. This method doesn't exist within our class. Luckily, it's a method defined in the monoBehavior class. Thanks to inheritance, we have access to it. It'll output a message to the console. The message can be configured by passing in a string. Let's output the following message. Price is too low. The print method is beneficial for debugging code. We can output custom messages to help us track changes and behavior from our class. Let's give our code a test. Switch over to Unity. Next, enter prefab edit mode for the robot. As we do so, the price gets updated. That's great. We can rest easy knowing the price will never fall below a threshold. Disasters can be avoided when someone tries to apply a discount lower than anticipated. The code from the else statement never gets executed. Let's try triggering it. Head back to the text editor. Inside the calculate price method, set the discount to 0.7. Next, head back to Unity. We're going to exit and enter prefab edit mode for the robot. This time, things are different. If we look at the price, the original price has not changed. This means the if block was never executed. What about our custom message? The print method will display the message from within the console window. This window can be found next to the project window. As you can see, the message from the else block gets rendered. That's perfect. We can be made aware of errors before they get out of hand. This information can help us by reminding us to use a more reasonable discount. Before ending this lecture, there's one final thing I want to mention. You may receive an error from Unity regarding an unused variable from our class. If you encounter this error, you can safely ignore it. It's not going to break the game. One last thing. Unity may forget to clear the console when files are updated. You can manually clear the console by pressing the clear button. This button removes all messages from the console. Be sure to clear the console during updates to your codebase. Otherwise, you may receive messages from older versions of your code. In the next lecture, let's cover an alternative solution for writing messages to the console.